Dear students, welcome back to the next session of classification of elements and periodicity in properties. Here we will going to discuss about the points periodic trends in chemical properties that included periodicity of valence or oxidation states, anomalous properties of second period elements, chemical reactivity. Periodicity of valence or oxidation states. The oxidation state of an element in a particular compound can be defined as it is the charge acquired by its atoms on the basis of electronegativity. Oxidation state is also formed by the number of valence electrons that carries charges. In a group, it remains same. Take an example, first group elements, alkali metals. All the alkali metals carries +1 oxidation state. Then similarly for the second group elements, alkaline earth metals, that shows the +2 oxidation state. Then some of the group elements with few exceptions are there. In a period, the normal oxidation state first increases then decreases. It depending upon the two scale, oxides and the hydroxide scale, oxides and the hydride scales. Periodicity of valence or oxidation state. Valence is a combining capacity of the element. It is formed by number of valence electrons. Number of valence electrons that forms the valency. The valence of representative elements is usually equal to the number of electrons in the outermost orbitals and are equal to the 8 minus of the number of the outermost electrons with respect to hydrogen scale. See students, the valence of representative elements. Representative elements are S and P block elements together called the representative elements. They usually equal to the number of valence electrons. Valence electrons are the electrons present in the outermost orbit. So the first group elements, that the valence electron is 1, that shows the valency of the 1. Here the given below, some periodic trends observed in the valence of elements are shown in the table. Number of valence electrons in first group 1, in second group 2 S block elements, then in P block elements, because representative elements usually S and P. 13 family elements, the number of valence electrons are 3, then for the 14 family elements it is 4. Please make it correction, this is 4, then 15, 5, 16, 6, 17, 7, then 18, 8. Noble gases. They are complete stable electronic configurations because there the octet is complete. If 8 electrons are there, then we say to be stable. All the noble gases are the stable because they are completely filled orbitals, completely filled by the 8 electrons except helium. So their valency is 0. Next, valency of the first group element is 1, second group element is 2, 13 family elements 3, 14 family elements 4 because 4 valence electrons. Then the 15 family elements 3 and 5, 16, 2 and 6, 17, 1 and 7. See here, number of valency goes on increases, then later on decreases. This is for hydrogen scale. With respect to the hydrogen scale, first valency goes on increases up to 1 to 4. Later on it decreases 4, 3, 2, 1. Take an example of lithium hydride. Lithium hydride, 1 valence electrons of lithium, 1 valence electrons of hydrogen. So it forms the 1 bond. Combining capacity is 1. So lithium is from the first group elements. So their combining capacity is 1. Like that up to the 17th group, first 1 to 4, the valency goes on increases, later on decreases to the 4 to 0. 0 in case of the noble gases. With respect to the oxygen scale, valency goes on increases because number of valence goes on increases. See, 1, 2, 3, 4, 5, 6, 7, then 8 for the noble gases. Here make it correction, 14, 4. Then in case of the oxygen scale, valency goes on increases. So, valency or combining capacity is also increases. 1 to 4 it already increases. Then in 15 family elements it shows the 5, 16, 6, 17, 7, 18 group 8 it is completely stable, so they can taken as valency 0 for the noble gases or the 18 family elements. Why here it shows the 3 and 5? Because 5 valence electrons, in order to complete its octet, it wants the 3 electron. So in hydrogen scale it shows the 3. Then it consisting of 5 valence electron. In oxygen scale it forms the combining capacity of 5U. In case of 16 family elements, oxygen family elements, the valence electrons are 6. So it shows the 6 valency. Then in order to complete its octet, it wants 2 electron. So it shows the 2 valency in case of the hydrogen scale. Then halogen family elements. 17 family elements are halogens: fluorine, chlorine, bromine, iodine, astatine. Here there are total 7 valence electrons are there. In order to complete its octet, it wants 1 electron. So it accepts the 1 electron, in the sense it shows the valency of 1. Then there are total 7 valence electrons. So in case of oxygen scale it shows the valency of 7. Difference between valency and the oxidation state. Valency is the number of electrons present in the outermost shell of particular element. Means it shows the combining capacity of the element. But oxidation state is a number of electrons that a particular atom can lose or gain or the share with the another atom, that consisting of the charge. Either it may be positive or the negative charge. By losing the electron, it shows the positive charge called the cation. By gaining the electron, it shows the negative charge called as anion. It does not indicate the electrical charge of an atom in a compound. What? Valency. But oxidation state indicates the electrical charge of atom in a compound. Valency determines the maximum number of bonds that an atom can have, but oxidation state does not indicate the number of bonds that particular atom can have. Valency of a pure element depends on the number of electrons it has its outermost shell of an atom, called the valence electrons. Depending upon the valence electrons, they will say the valency. But in case of oxidation state of a pure element is always 0. For example, element like Cu, Fe, in the elemental state, the oxidation state of pure element is always 0. Anomalous properties of second period elements. The second period elements are lithium, beryllium, boron, carbon. Then it is in relation with the third period elements. Let us see what are those anomalous properties of second period elements. First one is about diagonal relationship. Sometimes an element in the periodic table shows similarity of the properties with another element of the next group and next period diagonally. Such types of relationship between the two elements are known as the diagonal relationship. See here, this second period element shows the properties similar to the third period elements of diagonal next period to the diagonal elements. Lithium shows the property similar to the magnesium. Magnesium shows the property similar to the lithium. Aluminium shows the property similar to the beryllium. Silicon shows the property similar to the boron. These diagonal elements shows the properties similar. Similarities in the properties of the another element of the next group and the next period are in diagonally. They shows the same property. That is called as the diagonal relationship. See students, lithium and magnesium diagonal relationship. Beryllium and aluminium relationship. Boron and the silicon relationship. Diagonal elements are lithium and magnesium here, beryllium and aluminium here, boron and silicon. So diagonal relationship is the resemblance of the properties of the elements of second period with their diagonality opposite members, they lying in the third period. Second period and third period, they are lying diagonally. Diagonal elements shows the similarities in properties. Let us see why they show the properties. What are those properties? So the statement or the definition of diagonal relationship is what? Some elements of certain group of second period, it resembles much in properties with the elements of the third period of the next group. That is, elements of the second and third period are diagonally related in properties. This phenomena is known as the diagonal relationship. Diagonal relationship means some elements of the certain groups of the second period, it resembles much in properties with the elements of third period of the next group. That is, elements of second and third period are diagonally related in properties. This phenomena is known as diagonal relationship. So here the second period elements are lithium, beryllium, boron, carbon. Third period are sodium, magnesium, aluminium, silicon. Lithium shows the property similar to the magnesium, beryllium to the beryllium to the aluminium, boron to the silicon. Why this shows the similar properties? What are those similar properties of the elements? Both the lithium and the magnesium or the beryllium and the aluminium, boron and the silicon, they are small size of these atoms and high electronegativities of these. Then the charge to the large charge to the radius ratio means charge by the size ratio means the polarizing power ratio is large. Then these elements also have only 4 valence orbitals available. Means there is a availability of the only p orbitals, they can form the p pi multiple bond. So 2s and 2p for bonding as compared to the 9 available 3s, 3p and the 3d to the another members of the respective groups. So they shows the